Hello! In this video we will learn what the center of mass is, what it is useful for, and how to calculate it. Sometimes we will have a body that is made up of multiple parts that are attached together. In that case we can define some point as being the center of mass of the body. In other cases we can have a system of unattached particles. In that case too we can assign some point in space as the center of mass of the system. Additionally, any real object has its mass spread out over some volume. However, we can define a center of mass to the object. So what is the point of finding the center of mass? Well, for one thing, if an object or a system is spread out over space, how can you assign it a location? Well, we use the center of mass to describe its location because that is a single point in space. When talking about linear motion, it is this center of mass point that moves according to all our formulas, like F equals ma or like x equals vt. Let's think about the example of projectile motion. When we launch a projectile in the air, gravity pulls it downward, and the particle has a trajectory that looks like a parabola. Now, if you launch a golf club through the air, we have something similar. It might be spinning as it flies through the air, but if you only look at its center of mass, marked with a red dot, you'll find that that point travels along a parabola. No other point does that. They all have this more complicated path due to the spinning. So the center of mass is the point to pay attention to when you want to talk about linear motion. Another interesting point, the natural axis of rotation of any object will pass through the center of mass. You can see here in this example that the golf club is rotating around the center of mass. Of course, you could force this golf club to rotate around any axis if you hold a certain point in place, but let the rest move, like when you swing the golf club and hold it from the top. But if you just toss it through the air, the axis will naturally pass through the center of mass. Another example, if you shoot fireworks out, it will have a certain velocity. After it explodes, the particles go every which way, but due to conservation of momentum, the center of mass of the system has the same velocity immediately after the explosion. As time goes on, the center of mass will follow a parabolic trajectory, the same one that the fireworks would have followed if it had never exploded. There are other uses of the center of mass as well. For instance, if gravity acts on many parts of a system or body, then you can simplify it and say that gravity only acts on the center of mass, with a magnitude equal to the mass of the whole system times g. Hopefully that was enough to convince you that this is worth learning. So now let's learn how to calculate the center of mass. Imagine we have these three objects, of different masses and at different positions, all on a line. To calculate the center of mass, we can use this formula. That looks scary, but it will be less scary if we look at what it means in our case. In our case, it means this. It is the position of each object times its mass, and then we add them all together. We then divide that by the total mass, which is the sum of each item's mass. So let's assign some numbers and calculate this. We plug in the numbers, and we get this. After doing the arithmetic, we get this. So the center of mass is a bit off to the left of the center. Note that this tells us how to find the center of mass in one dimension. In two or more dimensions, we simply substitute the x for a vector r. This just means that we can calculate the x-coordinate of the center of mass as before, and we can calculate the y-coordinate with this equivalent equation. Together, those coordinates form the location of the center of mass. If all items are equally spaced and have the same mass, you can easily show that the center of mass is located at the central item. Because that is true, if we have an object whose mass is evenly distributed throughout, like a bucket of water, then the center of mass is simply the center of the object. So if we have a circle or a sphere with an evenly distributed mass, then the center of mass is at the center of the circle. If we have a square or a rectangle, then the center of mass would be here. And that's it for this video. Thanks for watching.